Hello everyone, welcome to my presentation on content, data, and DITA walks into a bar. My name is Mark Lewis from Caliper Content Services, and I am the principal content strategist and co-founder. You probably know me from different books that I've contributed from and over in the past years. I'm also the owner and manager of the LinkedIn group DITA Metrics, and many years ago wrote the book DITA Metrics 101, available out at lulu.com. I'd like to say special thanks to our partners, DataVid, data scientists and AI gurus, winner of the recent MarketLogic Partner Award, and to Data Guru Tom Comerford out at Supertext. Thank them for their contributions to this presentation. So what I want to do is take you on a journey about DITA in my documents. Well, many years ago, when I first started as a lowly technical writer using DITA, I was dealing with documents that were only about content. And it was nice and it was easy and it was fun. And as I learned about the power of DITA, we talked about it at presentations, about the reasons that organizations moved to multi-channel publishing, translation, and content reuse through the power of XML. So a company could go to XML for any of these three reasons, or sometimes just a single one of them. In later years, we started talking about the ability and need for governance of content and to bring in features into software that helped with content automation of manual tasks. So these were the things that we learned about in early days of getting to know DITA. I also learned that you need to have a strategy, and not just a content strategy, but there are sub-strategies that go along with it. Your metadata strategy, reuse strategy, and translation strategy. And these we came to know as a unified content strategy. And all is good because all is content. And DITA supports all of this. Then I started encountering data in my documents. Now, these were documents that were of my customers, because at this point, now we're designing, authoring, and reviewing solutions for a lot of different customers and a lot of different industries. And so we started seeing these islands of data, these chunks of data inside of our documents that appeared in, well, at first, it was a lot of financial reports of different companies and different documents of financial institutions. Here we've got a marketing brochure for stocks and bonds. And we see these chunks of data that were put into tables. So like tables of raw data. But there were patterns. I mean, it was consistent. You would see some of these pieces of these patterns of data over and over. So, for example, like the one on the screen here, statement of operations. These different pieces of data about each year. And so we were storing this data in a basic DITA table. And you can see that there's just basic table tags, but none of them are semantic. We really don't know what each piece of data is. But DITA is extensible, and we said, okay, well, let's take these unstructured tables, this unstructured data, and let's design a model for it using DITA, because DITA is extensible. We need a semantic model, semantic table to hold this data so that we can do more with it. Put some intelligence into the data, just like we put intelligence into content. And so if we wanted to design a model for this, what would it look like? Well, we've got the statement of operations, And for every entry, we've got the year, cost of revenue, total gross profit, this pattern of values that we see. And so we could design a model for this in DITA to hold that information. What might it look like? Well, here's an example. We see that we've got our, we just have our title as statement of operations, but you can see, this quarter of 2025, you can see the years, you can see revenue, you can see cost of revenue, gross profit. So now instead of just basic tags from a table, we have semantic tags and we know what each piece of content is. Now we have structured data. In addition, let's think about, you've seen tables in your documents for decades, and those have even been, they need to be reusable. So we can have basic tables that we could wrap in metadata to make them findable, adaptable, reusable. Well, now, what about these tables of data? Those need to be reusable too, because we were finding that the same chunks of data were repeating themselves or occurring in multiple documents and in multiple document types. So we need to, just as we make content reusable, we need to make these pieces of data reusable too. And data is extensible, and we can bring this into our reuse strategy because we can design whatever metadata we need to make the data reusable and findable. DITA supports this. So then we started seeing that some of the data was being represented as an image. And these could be pie charts and bar charts, or charts like you see on the screen here. And a lot of times we were understanding that this data could be pulled using a query. Okay, so now instead of just tables of data in our documents, now we've got data that's being displayed as an image that came from a query, right? Well, how do we handle that? Well, using DITA, we designed several elements. So we designed an element to contain the query, so it could reside in the document, and it would just get updated. Say if it was a monthly document, the month, the end month, the final date, could be increased every month. But this is just a string, like a SQL query. So a string to hold the query, and we could design that in DITA. And then we have the model that we designed for our structured semantic table to hold the result of the query. So we've got that covered. And then we could design a figure that would be a high fidelity representation of that data, if you will. And then we can wrap it with whatever metadata we need to make it reusable. And we did it all in DITA because DITA supports it all. Let's look at even a little bit more complex example. So lately, I've been looking at these very complex documents that contain a lot of content and a lot of data. And these are pesticide labels. And if we look at the content that's on just the cover page of this pesticide label, we can see that it has pieces of information, a mode of action, indication, is it a fungicide, herbicide, insecticide, etc. A description. What are the active and inactive ingredients? Signal word, warning. In addition, we've got these pieces of data that are embedded in these PDF documents and Word documents that, yes, you could store them as text, but it would be a lot better if we turn this into intelligent content and intelligent data and made these actual pieces of data for the active ingredient concentrations and the other ingredient concentrations. So a mixture of content and data. Now, further along in these labels, we encountered a lot of data. And so when you go to, for a agricultural product, apply it to crops and pests, you have a lot of instructions. And in the instructions chapter, we would see these tables that are essentially, these are rows of data. This is a scenario of, for this crop, for this pest, how much product do I use? How many times a year or a growing cycle can I apply this product? What's the maximum amount of total product that I can apply over a year or over a season? And how long before I can send humans into the fields to harvest this? So there's this and many, many more pieces of data that we were finding in these labels. Now, again, this could all just be text, but what if this could be all these pieces of essentially data could be stored as structured data? And so that's what we did. We designed a model for it, just like we designed a model for those statements of operations. And we did it in DITA because DITA supports this, because DITA is extensible. So a very complex document, but we were able to do all the modeling in DITA, and it works. So we've been talking about for years documents with content Legos. Well, now we've got data Legos that we have to deal with. And so we've got content about data and data about content, and all of these two different types of Legos. I like to call these composite documents because you're taking libraries of reusable content and reusable data, and you're assembling these documents into this composition, and then you can be putting in some local content here and there, maybe a lot, probably a lot, but it's a composition. So composite documents, if you will. So we've covered a lot, and it kind of feels like this could be complex, but I want to take a step back and look at the definitions of what we've been working with over the years. So let's look at the definition from the book. We have the intelligent content primer, modular, structured, reusable, format-free, and semantically rich. There's our model, there's our tags, our semantic tags. That gets us discoverable, reconfigurable, adaptable. Okay? The capabilities that we get. So intelligent content, structured content. If we look up a definition for structured data, what do we find? You will find discussions about the concept of the fair data principle. So here's the definition from the National Library of Medicine, posted in 2016. Findable, accessible, interoperable, reusable. Sounds kind of similar, doesn't it? Let's turn this into a list. Let's bring the two definitions together. So I took the most parts that were in common and on the left and swung them down to the bottom of the table, list rather. Discoverable versus findable and accessible. Okay, similar. Reconfigurable and adaptable. I am sure that the structured data that we can design would be set up for reconfigurability and adaptability. Interoperable. Well, if we have a schema for content, we have a schema for our structured data, that allows the files to be passed back and forth between different systems. So that's when that schema is machine readable, that's what's possible. So I kind of like bringing the term interoperable over to the intelligent content side. And reusable content, reusable data. So some very interesting parallelism here, similarity between these definitions, probably because of the need of what the structured content needs to do and what the structured data needs to do. So, Content Tribe. We've got our CMS, we've got our content warehouse, and we design libraries of reusable content. This design and all of the strategies are our responsibility as the content engineers, as the content strategists. Well, wait a minute. Now we've got queries going out to data hubs and data warehouses, pulling in data. We may be storing these as a reusable data, but this is really the design of all this is the responsibility of those data guys, the data engineers, right? So we need to collaborate with them because we have these composite documents that we're pulling in reusable content and reusable data. We're pulling components in from both warehouses. So we need to play well with the data guys and get our strategies aligned between them. So we think about the different strategies that we have: content strategy, metadata, reuse, translation strategies for content, and similar strategies that we need for data on the right. Translation for both as well. So where do we start? How do we align these strategies? Well, I think the easy place to start is, well, think about reusability. How do we reuse content? How do we make it reusable? So determining your reuse domain, all the different audiences you need to reach, and how you need to, how and can you reuse content. You will design your metadata for your models to facilitate your reuse strategy. So what pieces of metadata do you need to add to each model to make it findable, accessible, and reusable? And you do that for both the content and you do that for the data as well. And so I think that's the starting point for getting all of these strategies in alignment. And maybe we call this a unified component strategy. An interesting name. Let me know what you think. So within these strategies, we've talked about terminology management for decades. And so you have these vocabulary terms that appear in your content that you want to be consistent. You want writers to use them consistently, and you want them translated consistently. So that's part of your terminology management. These terms can be part of the data too. So you can have not just numbers, but you can have data that is that appears within these documents, such as the pesticide label example. You can have terms for application method, aerial, ground, irrigation, drip, and these appear within paragraphs. They can also appear as terms within the data in these scenarios that we see. Application timing, post-emergent, pre-emergent, appearing in the paragraphs and in tables of data throughout the document. So you need to have consistency in this terminology that's in both the content and the data. And so you can see that, again, we talked about how having controlled vocabularies is important for your translation strategy for both content and data. Let's talk about AI just a little bit. So, bullet point number 1, automated writing of content. Not going to cover that here today. Plenty of other sessions covering that, I'm sure. What I want to talk about with AI is the age-old problem of an organization starts using a structured content authoring solution. And then they say, we love the solution. We have the strategy to make maximum use of it. But what about all of our old documents? How do we get them into XML? All the content's buried in Word and in PDF documents. Well, now, let's say you're working with a document that has data embedded in there. So the migration problem increases because now you need to digitize these documents and create structured content and structured data. I have seen some fascinating leaps of progress in AI in this digitization world. We use it. I'm amazed at how well it works. But how can we help it? Well, let's think about back to the terminology management and those controlled vocabularies. So if we get those harmonized for both content and data, we can use those to teach the AI to hunt smarter. Look for those terms. Look for these terms in the content. That'll help you find the pieces of content that you're looking for. Go hunt for these terms in tables of data that will help you find exactly what each piece of, what a number is. So the AI can hunt smarter using these controlled vocabularies to train it. Okay, so now I understand that a lot of this depends on how consistently written the old documents are. Sometimes they are, sometimes they aren't, but still, the AI will work better using this technique. And if we had more time, as part of this unified component strategy, we could talk about intelligent graphics and bringing them into your strategies. But that's a topic for another day. So, key point is, if you're encountering data in your documents, don't be afraid, because data is extensible and we can design models to hold it all. You just need to plan ahead and unify your models and your strategies to support all this. And DITA will help you support it all. It would not be one of my presentations if I did not make a joke about intelligent content, so here we go. So we were talking about digital pesticide labels and our journey of finding data inside of them. The concept of smart farms has been around for a while, and now we're combining those two together, and we're taking data from inside these digital pesticide labels, and we're feeding it into driverless tractors to help them drive around. So maybe we shouldn't be afraid of Skynet. Maybe we should be afraid of FarmNet. All right, everybody. I hope you enjoy the rest of DITA World. Thank you for your time. And again, my name is Mark Lewis from Caliper Content Services. Reach out if you have any questions. Coming up, we've got Hannah and Christian from Kone Corporation, who sells escalators and elevators globally. And they are delivering intelligent experiences to a global audience. So I think they're probably going to have some interesting challenges with that. I want to hear their journey where they talk about that, and should be pretty interesting. Check it out.